For decades, our understanding of the outer solar system was defined by a single assumption, that it was a dark, static deep freeze. Even our most powerful telescopes could only resolve Pluto as a smattering of pixelated gray blobs. To find out what was actually out there, NASA launched the New Horizons probe. It needed to cross billions of miles of empty space as quickly as possible, blasting off on an Atlas V, a fully boosted rocket that whizzed past the moon in only 9 hours. The mission performed a gravity assist at Jupiter, using the planet's massive orbital momentum as a slingshot to accelerate. This maneuver shaved 3 entire years off the arrival time. When it finally arrived in 2015, the probe sent back images that proved decades of scientific assumptions wrong. Instead of a heavily cratered static rock, New Horizons captured a world of mountains, ice plains, and glaciers. Pluto proves that a world can be small, distant, and extremely cold while remaining geologically active, showing that even the darkest edges of our solar system are capable of change. At -229 degrees Celsius, nitrogen ice acts very much like liquid water on Earth. It flows through gaps in craters and mountain ranges, creating massive, slow-moving glaciers that reshape the terrain. These glaciers flow across Sputnik Planitia, a nitrogen ice plain the size of Texas. The region is almost entirely free of impact craters, which means the surface is relatively new, likely less than 10 million years old, and is constantly renewing itself from within. While the nitrogen is fluid and shifting, water ice on Pluto behaves like solid rock. It is the only material found on the surface strong enough to support the weight of mountain ranges that reach several kilometers into the sky. This dynamic environment extends to the atmosphere. As surface ices turn directly into gas, they create a 20-layer haze that shifts in density through Pluto's 248-year seasonal cycle, meaning the planet's appearance likely changes drastically over time. We can see evidence of this internal energy in the deep cracks stretching across the surface. These fractures show the crust is moving apart rather than folding, an indicator of expansion that suggests Pluto began with a hot interior and still harbors a massive subsurface liquid ocean. With internal heat and shifting chemistry, Pluto operates as an active engine of planetary evolution, constantly overwriting its own geological past. Just 19,000 kilometers away sits Charon, Pluto's largest moon. It provides a stark baseline to measure exactly how unusual Pluto's activity is. Because Charon is so large relative to Pluto, the two are tidally locked, orbiting around a shared center of mass called a barycenter. This invisible point in space acts as the anchor for their eternal gravitational waltz. Despite their proximity, the two worlds are chemically distinct. While Pluto is dominated by nitrogen, Charon is a static world of water ice. It lacks the volatile gases needed to create an atmosphere, leaving its surface frozen in time. Yet Charon has one major visual anomaly, a dark red cap covering its northern pole that stands out against its otherwise gray surface. Because Pluto's gravity is so weak, organic compounds called tholins escape into space during eruptions. These red particles cross the void and settle on Charon's pole, where the two worlds' tidal lock ensures the material always lands on the same spot. Charon serves as the ultimate frozen foil, a geologically dead canvas whose only dynamic feature is physically painted on by its neighbor. After the Pluto flyby, New Horizons pushed 1 billion miles deeper into the sparse, uncharted territory of the deep Kuiper Belt. 6.5 billion kilometers from the Sun, it encountered Arakoth. It is a bizarre, flattened object made of 2 distinct lobes that have fused together, known as a contact binary. Unlike Pluto, Arakoth lacks impact craters because its surface is being renewed. Instead, it is empty because time and impacts have effectively stopped here. Orbital speeds at the edge of the solar system are incredibly slow. When objects do cross paths, they don't shatter or fragment like the asteroids found closer to the Sun. Instead, these 2 lobes drifted together and merged at a walking pace. They bumped into each other at no more than 2 meters per second, gently fusing at their edges without creating fractures or stress lines. Its red coloring confirms it contains the same organic tholin compounds found on Pluto. But on Arakoth, these materials have remained chemically undisturbed since the solar system first formed billions of years ago. A rock oath serves as a flawless time capsule. It proves that the edge of our solar system isn't a wasteland, but a preserved timeline showing exactly how planets are born and grow.